and I want to share my screen. And since we were just talking about the midterm, I know that you are aware, at least, that the midterm is due by Sunday, March the 12th at 11:30 p.m. Again, I do have to manually grade some of those. I will start probably trying to work on that tomorrow. And as soon as I manually grade it, your score will populate and you'll be able to see it. So
Okay.
I know you've taken it. So, but for any student who's watching the recording, if you have not taken your midterm, you must take it by Sunday, March the 12th at 11:30 p.m. And to allow for the full 2 hours to take it, you need to start no later than 9:30 p.m. Tonight, I hope we're able to look at test for normality. That finishes up the lesson from last week that we had to kind of leave hanging. And then we're going to begin the next lesson, which will start with a one mean Z, and a one mean t-test. So quiz 7, which will cover hypothesis testing and the test for normality, is due by Wednesday, March the 15th at 11:30 p.m. Mini project 3, which covers normality, will be due by Sunday, March the 19th. And then if you are considering withdrawing from the course, the deadline is Monday, March the 13th. So as soon as I grade your midterm and I know kind of where you stand in the course, if I'm concerned about your performance in the course, I will reach out and let you know, hey, you may want to think about withdrawing. At this moment, I'm not aware of anyone that is in that boat. I will remind you at this point of the semester, it's a good time to remind you that for the BBA, for the Bachelor's of Business Administration, you do have to earn a C or better in this course. That is a requirement. So just to make sure that you're aware of that. So do you have any other questions for me, Deidre, since at the moment you're the only one in the room?
No.
Okay. So we are going to get into the test for normality. Last week, let me see if I can pull it up. Last week, we walked through the hypothesis testing process, the steps that you use whenever you are conducting a hypothesis test. And I had a set of fill in the blank notes that I hope you still have. So if you have those from last week, you may want to keep them nearby because we're going to begin working through several different types of hypothesis tests. The first type that we're going to consider is called the test for normality. And so I'm going to open up the PowerPoint that is available in the course. And we're going to take a look at some of the kind of the high points related to normality. What is it? What is this test for normality? So normality tests are used to determine whether the sample data has been drawn from a normally distributed population within some tolerance. You have, can be maybe a little bit off one way or the other. Remember that the normal distribution is one of the most useful and most used probability distributions in all of statistics. And so knowing that our variable is normal or that our sample was taken from a normal distribution is really very helpful, because that means then I can use a variety of statistical analyses that require that assumption. And so we usually, in our problems, it'll usually say, assume you have a normal distribution, or assume the distribution is normally distributed. Okay, but we don't have to make that assumption. There are tests that we can do to determine whether or not we have a normal distribution. And there are lots of different ones that, again, as I pointed out, you can use when you have normal data or parametric data. We can do a one mean t-test, we can do a two mean t-test, a one-way or a two-way analysis of variance, or just a handful of them. But again, there is a variety of ways that we can determine normality. There are different normality tests. We are only going to discuss one of those normality tests. And the one that we are going to use is called Anderson-Darling. Okay, so we're going to use the Anderson-Darling test test of normality. Now, Minitab is going to give us a graph and give us the test statistic that we need in order to make the decision. So the Anderson-Darling test is a statistical test of whether or not a data set comes from a certain probability distribution. The most common use is testing whether your sample, your small group, comes from a normal distribution. Again, if I know that it's a normal distribution, then I can apply things like the one mean t-test or the two mean t-test, or the one-way or two-way ANOVA. It opens up a world of analyses that I can do if I know that I have a normal distribution. So we actually conduct a hypothesis test. And so if you'll recall, the first step in a hypothesis test is to state the hypotheses. And the hypotheses for the Anderson-Darling test are the same every time, all the time, regardless of the variable. So the null hypothesis, which is denoted, remember, by H sub 0, we say the sample data, or the data, you could use whatever the variable is, but we say the data follow a normal distribution. Remember, let me kind of put some connections here for you if I can. Remember that the null hypothesis must always contain equal in some form. And so the concept here is that it follows a normal distribution, or is, quote, equal to a normal distribution. Okay, so the wording there, the sample data follow a normal distribution, implies that it's equal. And the null hypothesis must always and forever contain equal. The alternative hypothesis is the exact opposite. Well, the opposite of equal would be not equal. And so it says the sample data does not follow, okay, which again has that connotation and means not equal. Now, for whatever reason, and I haven't ever figured out another way to say it, students have struggle with getting the hypotheses stated correctly. Guys, the null hypothesis has to contain equal in some form, either by the phrasing that's there, it has to imply that it's equal, or it could imply that it's less than or equal or greater than or equal. The alternative is the exact opposite. Okay, but for whatever reason, students really struggle with making sure which one is which. Please remember the null hypothesis must always and forever contain equal in some form. So for Anderson-Darling, our null hypothesis will always be the sample data follow a normal distribution. The alternative will always be the sample data does not follow a normal distribution. And then we're going to go through and calculate our statistics and get the p-value. And ultimately, we have to make a conclusion. The way the conclusion is written for Anderson-Darling is the same every time, all the time. And it would read, or you would write, preliminary analysis showed that the data set for the, whatever the variable is or is not normally distributed as assessed by AD, which is Anderson-Darling, with a p-value equal to whatever it's given. Okay, now we're going to work through some examples, and I will use this exact phrasing to do it. Okay, that's the way it doesn't have to be worded that way, but that is the usual way that you see it. Okay, so Minitab's going to do the work for us. So this is slide 4, I think. Slide 5. Okay, so slide 5 of the PowerPoint on normality has the steps that you will use in Minitab to run the test. On slide 6, you have the first example. But we need the data in order to run the example. Typically for the test for normality, you will be given the raw data. You will have the list of individual data values. I provided the data set in the class, okay? It says the Institutional Effectiveness and Strategic Initiatives Department at GHC wants to know if the ages of students in fall semester 2022 are normally distributed. A sample of all students in 2 different Statistic 1401 classes at GHC are surveyed and the results are provided. Okay, so the results are in the course. If we go over to the home page for the course and navigate to Module 3 and the lesson on normality, on the landing page for that course, normality, parametric and non-parametric test, and p-values, I have data set for normality test examples. And example 1 is the Stat 1401 class survey. So I'm going to click on it and I'm going to save it and then open it. I notice that it's in an Excel format. Remember, to get it into Minitab, we have to copy and paste. So I'm going to copy and then paste it into Minitab. So I have just uploaded or pasted the Stat 1401 survey results. Okay, so I moved the question over to a Word document so we could work through it. It's a normality example because we're in the normality lesson. And the first step in any hypothesis test is to state the hypotheses. So step 1 is to state the hypotheses. There are always two. You have H sub 0, which is the null, and you have H sub A, which is the alternative. Usually you'll see them stacked like that, one on top of the other. The null, which is H sub 0, is on the top, and the alternative H of A is on the bottom. This is a test for normality, and you may say, you were asking earlier, what kind of clue did I have? Well, notice it says, wants to know if the ages are normally distributed. So I'm trying to determine if the variable of ages is normally distributed. Now, it doesn't come right out and say that, but again, it says it wants to know if it is normally distributed. So our null hypothesis, because this is a test for normality, our null hypothesis would be the ages of GHC students in fall 2022 are normally distributed. Or you could say follow a normal distribution. Okay, but the point is we're saying it is or equals a normal distribution, because the null hypothesis must always and forever contain equal. We know that the alternative is the exact opposite. So now that I've identified the one that's in the question, I can find the alternative, because it's going to be the exact opposite, which would be the ages of GHC students in fall 2022 are not normally distributed. So the first step is to state your hypotheses. Typically, the second step in the hypothesis test is to identify the players. Identify the information that you need in order to work the problem. Okay, in this problem, for normality, what we really need is the raw data. Okay, so we need the raw data, which would be the ages of stat 1401 students in fall 2022. And you have those because you have the spreadsheet that I provided. Step 3 is to calculate the test statistic and its corresponding p-value. Now, for this problem, the test statistic that we will calculate is the Anderson-Darling. And Minitab is going to do those calculations. So we're going to use app.minitab.com to find that answer. So I've already copied the data set in to Minitab. My focus is on age, which is in column 1. We go to Stat, Basic Statistics, Normality Test. It's near the bottom of the list. Stat, Basic Statistics, Normality Test. It asks me what variable. We're doing age. We do not want any percentile lines, and we are doing Anderson-Darling. I click OK. And Minitab gives me the probability plot. I select the graph, use the triangle in the corner to copy, and I can take it over to my paper and paste it. Okay, so you get the probability plot, and on the probability plot, you have the value of Anderson-Darling, AD, and the corresponding p-value. So my Anderson-Darling test statistic, okay, so AD is or was 7.020. 7.020. And it says the corresponding p-value, it actually says is less than 0.005. We're going to assume it is exactly 0.005. So I write those two things down because I need the test statistic and its p-value. Step 4 is we're going to make a decision. Remember, we have two options in terms of making the decision. We're either going to reject the null, which means the null is false or wrong, or we fail to reject the null, which means the null is true or correct based on the evidence that we have. We make that decision by using a standard guideline. And if you'll recall, the guideline says if the p-value is less than or equal to the level of significance, we reject the null. But if the p-value is greater than the level of significance, you fail to reject the null. Okay, so for this problem, from Minitab, I know that the p-value is 0.005. Now, the problem itself did not give us the level of significance. I mentioned this the other night, that if it is not given, the default or the most often used level of significance is 5% or 0.05. So my alpha is 0.05. So then I'm going to compare those two decimals. And again, for whatever reason, that comparison is an area that students struggle with. My suggestion is to do it digit for digit. Okay, so if I look at the p-value, the first number after the decimal is 0. For level of significance, the first number past the decimal is 0. So they're the same. The p-value has 0 in the second place. The level of significance has a 5. 0 is less than 5. So the p-value is less than alpha, or it could be equal. If the p-value is less than or equal to the level of significance, then we're told to reject the null. So there's my decision. My decision is to reject the null. To reject the null means the null is false or wrong. So the alternative is true or correct. Now, that's important because knowing what your decision is helps to frame and know how to word the conclusion, which is the last step in the hypothesis test. So I'm up to step 5, and I've got to write the conclusion. And we write preliminary analysis of the ages of stat 1401. Let me make a little bit more space. Students at GHC is not normally distributed as assessed by AD equals 7.027 and P equals 0.005. Now, you may be going, Miss Ralston, how did you know is not? All right, let me see if I can walk you through it. Based on the numbers, we said we were going to reject the null. Okay, if we reject the null, I'm going back up to my hypotheses. We're going to reject the null, which means the null is false or wrong. And so by default, then that means that the alternative has to be true or correct. And if you go back and look at your notes from last week, we said that you write the conclusion in terms of the true hypothesis. The true hypothesis said the ages are not normally distributed. So that's what I wrote in my conclusion. I said preliminary analysis of ages is not. I suppose I should have said are not, but you get the idea. Questions? I'm trying to be very deliberate and literally walk through the steps that were on our fill in the blank notes. Okay, so let's look at another one. Step 1 in any hypothesis test is to state the hypotheses. But I guess I should read the question first. I'm getting ahead of myself. It says, a local bank manager wants to know if the ages of loan applicants is normally distributed. Now, it so happens that in this problem, I selected the same variable. But again, we want to know if our variable is normally distributed. So that phrase, want to know if it's normally distributed, is the clue that I need to do the test of normality, which is a hypothesis test. And we begin every hypothesis test the same way, by stating the null hypothesis, which again is usually on the top, and stating the alternative hypothesis. For the test for normality, the null hypothesis will always say is or follows a normal distribution. Okay, so we're going to say the ages of loan applicants are normally distributed. Again, that phrase, are normally distributed, is the phrasing, has the implication that it's equal to a normal distribution. The alternative would say the ages of loan applicants are not normally distributed. Step 2 is we identify the players. We have to identify the information that we need. And for this problem, remember the information that we need is the raw data, which again, I gave you in Minitab, or excuse me, in the course. So example 2, loan applicants. Remember, I'm under hypothesis, p-values, and normality. And it says example 2. So I'm going to click on loan applicants. This one is a Minitab file. So remember, I'm not going to try to open it on my desktop. I have to go straight into Minitab, and I'm going to go File, Open the Worksheet I'm using worksheet because it had a .mtw prefix or suffix, excuse me. So I'm going to open it from the local file, desktop data sets, and we're doing loan applicants. And it automatically populates for me. So then I go to, so the third step, let me write the third step. Okay, so I've got my raw data now, entered into Minitab. The third step is to calculate the test statistic and its corresponding p-value. Again, the test statistic that we calculate here is Anderson-Darling. So I have my data set in Minitab for the loan applicants. I'm going to go Stat, Basic Statistics, scroll down to Normality Test. I have to choose my variable. Again, the variable that I'm interested in, again, in this problem is age. No percentile lines, and we are using Anderson-Darling. I click OK. And it creates the plot, the probability plot. I'm going to copy it and put it on my paper. So you have this plot. And again, you have your Anderson-Darling and its corresponding p-value on the right-hand side of this graph. So my Anderson-Darling is 0.659 with a corresponding p-value of 0.077. Then we move on to step 4, where we make a decision. Again, you make the decision by comparing the p-value to the level of significance. The problem didn't give us a level of significance, so again, we'll default it to 0.05. The one from Minitab for the test statistic is 0.077. I'm going to compare those digit for digit. So first number after the decimal point is 0 in both cases. 7 and 5. 7 is greater than 5, so P is greater than alpha. If P is greater than alpha, we fail to reject the null, which means the null is true or correct. The last step is we write the conclusion. Now again, let's go back up here and think through this. In this problem, we said we would fail to reject the null, which makes the null true or correct. And we write our conclusion in terms of the one that is true. In this case, the alternative is false or incorrect. Okay, so be careful, make sure you know what's what. So it does follow a normal distribution. So we would say preliminary analysis of the ages of loan applicants does follow a normal distribution as assessed by Anderson Darling equals, I forget the number, 0.659, p-value was 0.007. And there you go. Now, I know that a lot of students try to overthink it. And it does seem like a lot of steps, but it's the same steps for every type of hypothesis test that you're going to conduct. So if you'll get yourself, kind of train your brain to go through those steps each time you're conducting a hypothesis test, you'll be less likely to make a mistake. Questions? Okay, now that actually finishes the content that's on quiz 7. Okay, so just so you'll know, I'm going to make a note here that this is the end of the material on quiz 7, which is the quiz that is due by next Wednesday. Questions? All right, we're going to move then to the next lesson in the course. And let me navigate back where you can see what it is. Okay, so we're still in module 3. The next lesson in module 3 is 1 and 2 mean test, then Mann-Whitney, Wilcoxon, and Cohen's D. Okay, I hope we are able to get through at least the 1 mean test tonight, and then we'll kind of go from there. Okay, there are lots of PowerPoints. I also have the examples that we're working in class in a Word format, so you can download those. I also have the data set or sets that you may need for the examples that we're looking at. Okay, so it looks like a lot. So let's go to 1 mean and 2 mean hypothesis test. And I tried to break it up into 2 parts. So initially we're going to focus on 1 mean, and then we'll focus on 2 means. All right, let me get to where I can put my PowerPoint up. All right, so we're focusing on right this minute on 1 mean and 2 mean hypothesis test. Hopefully, you'll remember some of the information we do talk about and discuss 1 mean hypothesis test in Stat 1401. Now, I realize for some of you that's been a while. We do not discuss 2 mean hypothesis test unless you've had, well, not even if you've had it recently. We do not do 2 mean. Okay, so we're going to focus on 1 mean for tonight, at least now. Oh, and it's hung up on me. All right, let me get out of my PowerPoint. It's hung up again like it likes to do. Share the screen again.
Professor Ralston,
Yes,
I have a
ma'am.
question real quick. When we
Yes,
do our
ma'am.
homework, are we gonna need to use the Excel sheet, right? When we do our quiz? Or
I believe, let me look real quick, Deidre. I believe for that quiz, the data sets that you need are in the quiz itself, but let me double check real quick.
okay,
Okay,
thank you.
so let's see. Hypothesis testing, p-values, and normality. If I go into quiz 7, and I have to preview it so it'll look like it will to you guys. Oh, not gonna let me preview, huh? Maybe? No. Okay, I gotta get down here where I can preview. Why won't it let me? Well, I can look at it this way. Okay, for the question, it's going to give you a scenario. Deidre, are you with me?
Yes.
This is like scenario 2 on quiz 7. It says use the following mini-tab data. So I link to a data set. It's actually that one that I gave you, that loan applicant. So
Okay.
you'll need that data set, the loan applicant data set. But I have the link there. You can link to it and then download it. Or I have it where you can get to it in the course. Let me see about scenario 3. Okay, this is where you're looking at parametric and non-parametric. Okay, so I think all of the questions related to normality are going to link back to that data set on the loan applicant, which you have. Let me get out of this. It's embedded in the quiz itself, so you could download it again. But I also have it on the landing page for that topic. If you go into hypothesis, p-values, and normality. Okay, see, I give it to you. Loan applicants.
Okay, thank you.
You're welcome. All right, so I'm going into 1 mean test. So I mentioned that our focus, at least at this moment, is going to be on 1 mean. And there's 2 different formats or 2 different ways that these questions will be formatted. In some cases, you may be given the sample statistics. Minitab calls that summarized data. In other cases, you may be given the raw data. The raw data is where you get that list like we just had. The ones that we're going to talk about in this course are the one mean z-test, the one mean t-test, and then the two mean t-test for what we call independent samples and dependent samples. Those are two different tests. Hopefully you remember, you may not, but so I'm going to remind you, the difference between a one mean z and a one mean t is whether or not you know the population standard deviation. If you know the population standard deviation, then you will always do a z-test. If you do not know the population standard deviation, but instead know the sample standard deviation, then you run a one mean t-test. For our purposes in this course, that is the defining factor, is do I know the population standard deviation? If you say yes, you're going to do a Z. If you say no, we're going to do the T. So going back to Minitab, we're going to begin looking at some examples. Again, this is one of the topics. Hypothesis testing is one of the more challenging topics for students for whatever reason. Again, hopefully a lot of this is review, but I've given you the keystrokes that you would use in Minitab to conduct a one mean Z with summarized data. So I believe that's the third slide. Yes, it's on slide number 3. And then right behind that on the next slide is the example. Now, again, I have the examples in a Word document so I can make the notes as we go. Okay, so I'm going over to my example. And this one says, woo, Jeffrey, as an 8-year-old, established a population mean time of 16 seconds for swimming the 25-yard freestyle with a population standard deviation of 0.8 seconds. His dad, Frank, thought that Jeffrey could swim the 25-yard freestyle faster using goggles, and his time would decrease. Frank bought Jeffrey a new pair of expensive goggles and timed Jeffrey for 15 different 25-yard freestyle swims. For the 15 swims, Jeffrey's mean time was 15.8 seconds, and the standard deviation was 1 second. Did the goggles decrease his time? Conduct a hypothesis test using an alpha equals 0.05. Assume that the swim times for the 25-yard freestyle are normally distributed. Okay, so again, one of the questions, Deidre, that you asked me earlier was, how do you know what you're supposed to do? Well, the way this question is worded, towards the end, it tells you to conduct a hypothesis test. Your challenge becomes determining which one you should do. So if this were a question on the final exam, the instruction tells you to conduct a hypothesis test, but you're going to have to decide, because by the end of the term, we will have looked at about maybe 6 to 8 different hypothesis tests. So to decide which hypothesis test we're going to conduct, I need to kind of scan back through the problem and see what information that I know. So if I go back to the first sentence, I noticed at the first end of this first sentence, at the end, it said that the population standard deviation is 0.8 seconds. And so I could automatically stop right there. I really don't need to go any further because I know the population standard deviation. Because I know the population standard deviation, I will conduct a Z test. So I know I'm going to do Z. And then you may have to decide, is it one mean or two mean? But when we're doing a Z test, the only one we're going to talk about for this, well, not the only one, but this is a one mean Z test. It is Z because I know the population standard deviation. It is a mean because if I scan back through, it says population mean time, timed him, and the mean time was this. And so the problem itself is talking about the mean. And it's only talking about one mean, the mean for his swimming. The other Z test that we'll discuss towards the end of the term is a one proportion Z test. So for now, we only do a one mean Z test. So my instructions told me I needed to conduct a hypothesis test. My first decision really has to be which one. And based on the information that I have and the fact that I know the population standard deviation, I know I'm going to do a Z test. Ultimately, I have to decide whether it's for the mean or for a proportion. We ain't even got to proportion yet. And nowhere in the problem does it talk about a proportion, but it does talk about the mean. So then I'm going to begin the hypothesis testing process. The first step is to state the hypotheses. Now, for this scenario, or for the one mean Z test, determining your hypothesis is just a little bit trickier because you have to pay attention to the question. The question ultimately is, did the goggles decrease his time? Well, his time initially, we're told, is 16 seconds. But his dad thinks he'll go faster if he's wearing goggles. So he buys the goggles and he has the son try them out. So the idea that it decreases, we need to think about what math symbol that would be. Decrease makes me think of the word less than, which is the symbol that looks like this, which does not in any way include equal. So because the question says, did the goggles decrease, which in my mind means less than, and less than does not include equal, this statement or that question is the alternative hypothesis. One of the hypotheses is going to be stated in the problem. You just have to figure out which one it is. So his dad thinks that the mean time will decrease from the 16 seconds if he wears the goggles. So this is the one, and I'm going to make a little note here. This is the one that's given. So then I have to figure out with my head and my brain what the null will be. And I know that the null and the alternative are always the opposites of each other, and that the null has to contain equal. So it would be that the mean is greater than or equal to 16. And I'm using 16 because that's what it told me his initial population mean was. Do you have questions? That's usually one of the hardest steps for students, is getting the hypotheses identified.
I don't have any.
Okay, the other thing that I want to stress here, and I write it in there every time, but I know that sometimes when students start working through these problems, they leave it out. Guys, you have to put this symbol for the mean. That identifies to me that you're doing a mean, or to whoever's looking at it. Okay, that is the parameter that you are testing. So you have to have that symbol in there. Okay, so that is step one. Step two, we identify the players. And if you go back and look on the fill in the blank notes that we filled out last week, I gave you a list of the things you needed when you were doing a one mean z-test. You need the population mean, which is mu, and it's found in the hypothesis. You need the population standard deviation, which is sigma, and it should be given in the problem. You need the sample mean, which is x bar, and it should be given in the problem. You need the sample size, which is n, and it's given in the problem. You need the significance level, or the level of significance. That's alpha, and it's given in the problem. Now, one of the things you'll need for Minitab Minitab uses the confidence level. You will have to figure out the confidence level based on the significance level. Remember, they have to total to 1. So you need that for Minitab. But all of the information that you need is given in the problem. Remember, this problem or this category of problem is called summarized data. They've given you all the numbers. In fact, they've given you lots of numbers up in the story. Okay, so let me see if I can maybe color code this a little bit for you. Okay, if we go back and read, it says Jeffrey, as an 8-year-old, established a population mean time of 16 seconds. So the population mean is 16. It's written in green. Okay, and I'm scrolling back up. For swimming the 25-yard freestyle with a population standard deviation of 0.8 seconds. Okay, I already have it underlined in blue. Population standard deviation of 0.8 seconds. Okay, so the population standard deviation in light blue is 0.8. Keep reading. It says, he brought Jeffrey a new pair of goggles and timed him for 15 25-yard freestyle swims. So it says he had him swim 15 times. So for the 15 swims, that's my sample size. Okay, so he had him swim 15 times. That's how many samples I have. And I'm going to keep reading. Jeffrey's mean time was 15.8 seconds. So for those 15 swims, the sample mean was 15.8 seconds. And I keep going, and it says, conduct a hypothesis test using alpha equals 0.05. So my significance level is 0.05 or 5%. So by default then, let me see, let me choose a different color. I used orange red. Okay, so my significance level would be 1 minus alpha. So that's 1 minus 0.05, or it's 0.95 or 95%. Okay, remember your confidence level plus your significance level has to total to 1. Has to total to 1. And usually the confidence level is written as a percentage. Okay, now, do you need me to walk back through any of that of how I got those numbers? All of those numbers are given in the problem. They actually give you one piece of extra information that you do not need for this problem. It tells us that the standard deviation for the 15 swims, which would be our sample standard deviation, we don't need that. Okay, it's just extra information. Okay, then we move on to step 3. Step 3 is we calculate, the test statistic, which is going to be a Z, and its corresponding p-value. And we use Minitab to do that. Okay, so in this case, we will use app.minitab.com. So I'm going out to Minitab. Now the instructions I gave you for Minitab are on slide 3 of the PowerPoint. I'm going to walk you through it. I go to Stat, Basic Statistics, One Sample Z. I have summarized data. I need to enter the sample size, which was 15. I need to enter the sample mean, which was 15.8. The known standard deviation. Let me see, I wrote it down over here on a piece of paper earlier. The mean standard deviation or population standard deviation is 0.8, 0.8. I'm then going to conduct or perform a hypothesis test, and my hypothesized mean is 16. So I've entered all the information from the problem. I'm going to click on Options. I'm doing a 95% confidence level because the significance level was 0.05 or 5%. The alternative hypothesis, I have to choose which symbol is in the alternative hypothesis. We said it was less than or had decreased. So I need to choose that one. Guys, the selection of that symbol is important because it affects the calculations of your test statistic and the p-value. You have to look at what symbol is in the alternative hypothesis. Remember, we talked about which type test you have. Is it one tail or two tail? This is a one tail test because it contains less than. And the only option is to be less than. Once I've made all my selections, I click OK and OK again. And my results appear in the top screen. Okay, I have to scroll down a little bit because what I need is under the header labeled test. And I'm going to copy that over here to my paper. So from Minitab, you get the Z value, which is your test statistic. And then you get its corresponding p-value. You must write them down. Do not simply copy and paste. So my Z is negative 0.97. The corresponding p-value is 0.166. Step 4 is to make a decision. Again, your decisions are either you're going to reject the null, which means the null is false or wrong, or you're going to fail to reject the null, which means the null is true or correct. That decision is always made by comparing the p-value to alpha, which is your level of significance. My p-value is 0.166 from Minitab. My alpha from the problem is 0.05. Make the comparison digit for digit. The first digit after the decimal in the p-value is 1. The first number after the decimal for the level of significance is 0. 1 is greater than 0, so the p-value is greater than the level of significance. If the p is greater than alpha, you fail to reject the null, which means the null is true. And that's important to note because our conclusion is written in terms of the true hypothesis. So I'm going to go back up here and double check, make sure I understand what's true. Okay, we fail to reject the null, which means the null hypothesis is true and that the swim time was greater than or equal. It did not decrease. The swim time did not decrease based on the evidence that we have. So I'm going to say that in a sentence. And again, the conclusion for hypothesis test is written in a very specific way. You always include your level of significance. And I usually start the sentence that way. At the 0.05 level of significance, the goggles did not decrease Jeffrey's swim time of 16 seconds. And again, you want to put the details in there, but it's important that you indicate that it did not decrease it. It was greater than or equal. I mean, if you want to say it that way, that's fine. You could say the goggles caused his time to be greater than or equal to 16. There's different ways to say it, but it's important that you say it so that it implies that the time was not decreased. Questions? I think there's only 2 of you in the room, so do either of you have questions? Hopefully this is a little bit of a review. Deidre, are you all right?
I'm good, thank you.
Okay. So let's look at another one. This one, again, we're still looking at one mean Z. In this problem, you have the raw data. Okay, so the instructions in Minitab are on slide 5. Okay, so slide 5 is Minitab where you have the raw data. So let's look at how the problem is worded differently, or how it is set up differently, so that you can recognize that you have raw data. It says, a college football coach thought his players could bench press more than a mean weight of 250 pounds. It is known that the standard deviation is 25 pounds. 3 of his players thought that the mean weight was more than that amount of 250 pounds. They asked 15 of their teammates for their estimated maximum lift on the bench press exercise and got the following data. And then you have a list of numbers. Conduct a hypothesis test using a 0.01 level of significance to determine if the bench press mean is more than 250 pounds. Okay, so again, one of the first things I notice is it does tell me in this problem that I'm going to conduct a hypothesis test. But again, my first decision has to be which one. Well, again, if I go back to the beginning of the problem, it says it is known, okay, and the word known is used in Minitab to imply the population. So it's implied here, even though it doesn't literally say population standard deviation. Okay, it is known that the standard deviation is 25 pounds. Okay, again, that word known implies it is the population. So, because I know the population standard deviation, I will conduct a Z test. And again, if you look at the words, we got to decide between mean and proportion. And we ain't got to proportion yet. But again, if you go back and look through here, you see mean, mean. Okay, so again, I know I have a 1 mean z-test. So now that I know what I'm going to conduct, I begin the process and I state the hypotheses. We have the null and the alternative. One of them is stated in the problem. I need to figure out which one it is. This one's kind of nice because it kind of gives it to me at the end. It says, determine if the bench press mean is more than 250 pounds. Okay, so in this case, it uses the word is more than. Well, is more than makes me think of greater than, which is this symbol, which in no way contains an equal sign. So that clues me in that, again, this statement is the alternative hypothesis. So my alternative hypothesis is that the mean is greater than 250 pounds. Again, that's the one that's given. I have to figure out the null. It is the exact opposite. The opposite of greater than would be less than or equal to. The null has to contain the equal. Step 2 is we identify the players. Okay, we need the population mean. We need the population standard deviation. I have the raw data this time, so I don't need, see with the raw data, let me make you some notes here. With the raw data, you are not given the population mean or sample mean and sample size. Okay, they're not really given. I could figure out the sample size, but I don't have to. They're not given because you have raw data. Okay. So my population mean is 250 pounds. It comes from the hypothesis. If I go back up to my story, it tells me that the known population standard deviation is 25 pounds. Near the end of the problem, it says using a 0.01 level of significance. So alpha is 0.01. The confidence level then, remember, is 1 minus alpha. So that's 1 minus 0.01, which is 0.99 or 99%. This one, it is not summarized data. Minitab uses the phrase one or more data sets each in a column. My data is not summarized. I have a list. I actually have the data set. So step 3, whoops, sorry about that. Step 3 is to calculate the test statistic, which will be a Z, and its p-value. But to do that, I'm going to have to enter the raw data. Okay, so I have to put that list of numbers that's given to me in the problem into Minitab. So, if you don't have a printout, you may have to write the numbers down. I printed out a copy of them earlier for myself. So I'm going into Minitab. I'm going to get a clean worksheet. I want a new worksheet. And in the first columns, I'm going to put the bench press weight. And it's in pounds. Okay. And then I'm going to enter those 15 numbers. It's taking me just a minute to type them. Okay, I end on the 15th row, so I know I entered 15 numbers. I may want to scan back up through the numbers just to be sure that I didn't type something too wonky or mistype something, because if I mistype it, then my answers are going to be wrong. Okay, so once I have my data entered, here we go. Stat, basic statistics, one sample Z. I have one or more samples in each in a column. Where's the data? My known standard deviation was 25 pounds. It was given in the problem. I'm performing a hypothesis test. My population mean was 250. I'm using a 0.01 level of significance. So my confidence level is 99%. My alternative was that it was greater or more than. And I click OK and OK. Now, should you need it, notice here in this display in Minitab under the header descriptive statistics, Minitab has calculated, it tells me that my sample size was 15, the mean was 23, or I'm sorry, was 236.13. And the standard deviation for the data set, okay, which will be the sample, is 30.42. So if you needed it, Minitab does calculate the sample size and the mean for you. But again, what we need is under the header test. Okay, come on now. Oh goodness, where did it put it? Got a mess there. Hold on just a second. I'm trying to get it pasted where you can see it. Okay, there we go. Okay, so we have the results. Again, we write it down. So the Z test statistic is negative 2.15, and the p-value is 0.984. So then I'm up to step 4. Step 4, we're going to make a decision by comparing the p-value to alpha. The p-value from Minitab is 0.984. The level of significance was 0.01. Again, digit for digit. First digit in the p-value after the decimal is a 9. For the level of significance, the first one is a 0 after the decimal. 9 is greater than 0, so P is greater than alpha, so we would fail to reject the null, which means the null is true. Our final conclusion is written in terms of the true conclusion. So let's go back up here and check what that means. If I fail to reject the null, that means the null is true. So the bench press mean is less than or equal to 250 pounds. It's not more than. So I would say at the 0.01 level of significance, the bench press mean weight is not more than 250 pounds. Questions? Okay, I want to try to do one more. And the information for Minitab for this one is on slide 7. This one says, GHC statistics instructors believe that the mean score on the third statistics test is greater than 72. Over the fall semester, they collect data on 50 students who had an average of 75 with a standard deviation of 10. They perform a hypothesis test using a 5% level of significance and assumed the data is from a normal distribution. Is their claim true that the mean score of the third exam is greater than 72? Okay, so here again it says that the instructors perform a hypothesis test. Okay, so we kind of know we are doing a hypothesis test, but again, the first question that we'd have to ask ourselves is which one? And so if I go through again and I read through this, nowhere does it talk about population standard deviation. It does talk about a standard deviation, but this standard deviation is related to 50 students. So it says over the fall semester, they collect data on 50 students. Okay, so this is related to, it doesn't specifically say it, but it's related to the sample. Nowhere in here does it talk about population standard deviation. So because I only know the sample standard deviation I will conduct a t-test. Now we're going to be learning about a one mean t-test, a two mean t-test for independent, and a two mean t-test for dependent. So I've got to decide which one I have. I can again notice that it does talk about the mean throughout this problem. So I know that I'm talking about a mean. And then I have to decide, do I have two means or one mean? Well, the only thing they're talking about here is the third exam. That's one thing. So this is a one mean t-test. We begin the hypothesis testing process. The first step in any hypothesis test is to state the hypotheses. Y'all gonna think I'm a broken record because I keep saying the same thing. Okay, one of those hypotheses is given in the question. Again, it's kind of towards the end. It says, is their claim that the mean score of the third exam is greater than 72 true? Okay, so again, I see these words, is greater than. So again, I'm thinking greater than, which is this symbol. It does not include equal, so this statement is the alternative hypothesis. So my alternative hypothesis is that the mean is greater than 72. That's the one that's given. I can figure out the null because it has to be the exact opposite. So the mean is less than or equal to 72. Then we need to identify the players. And again, if you look on the fill in the blank notes from last week, I told you what things you would need to do the hypothesis test for a one mean t-test. You need the population mean, and I know I only have 10 minutes left. That comes from the hypothesis. You need the sample standard deviation, which is S and should be given in the problem. You need the sample mean, which is X bar and should be given. You need the sample size, which is N and should be given. You need the significance level, which is alpha, and it should be given. And then you will have to figure out the confidence level. Again, because you need the confidence level in Minitab. So all that information is given in the problem. Okay, so let me see. I got 8 minutes. Let me see if I can find you those numbers. Okay, the population mean is the 72. That comes from my hypothesis. I pointed out a minute ago that the sample standard deviation is 10. If I go back and read a little bit more, it says average of 75, and we had 50 students, and it asked us to use a 5% level of significance. So my sample mean is 75. My sample size was 50. My significance level is 5%, or written as a decimal is 0.05. My confidence level then would be 100% minus 5%, which is 95%. Step 3 is to calculate the test statistic, which is going to be a t and its corresponding p-value. And again, Minitab is going to do that work for us. Minitab's going to do the work for us. All right, so I'm going out to Minitab. Stat, basic statistics, one sample T. I have summarized data. My sample size was 50. The sample mean was 75. The sample standard deviation was 10. I am performing a hypothesis test, and they believed it was greater than 72. I'm using a 95% confidence level. The symbol in my alternative hypothesis was greater than. I click OK. I click OK. And again, under test, let me copy it over here to the paper real quick. Under test, you get the test statistic, which is now a t, and the corresponding p-value. Write them down. Okay, so my t is 2.12. The p-value is 0.019. Step 4 is you make a decision. It's the same two decisions we've looked at all night long. You're either going to reject the null or fail to reject the null. You make the decision by comparing the p-value to alpha, but be careful, the alpha should be in decimal form. So I have 0.019. That's my p-value. My alpha was 0.05 or 5%. So I'm going to compare these. The first number after the decimal in both cases is 0. Then for the p-value, the second number is a 1. For alpha, the second number is a 5. 1 is less than 5, so the p-value is less than or equal to alpha. If p is less than or equal to alpha, we reject the null. If I reject the null, that means the null is false and the alternative is true. So let me back up here where you can see it. So for this problem, we reject the null, which means the null is false. Therefore, the alternative is true. So in this case, the mean score of the third exam is greater than 72. And I have to say that. So the last step of any hypothesis test is to write your conclusion. The conclusion should always include your significance level. So at the 0.05 level of significance, the mean score on the third stat 1401 exam is greater than 72. Now, I do have another example where you have to do a one mean t with raw data. I'm going to leave that one because we've run out of time. And then next week, we will pick up with 2 mean t-tests. Okay, so let me remind you real quick. I stopped the share, but let me see if I can go back to it real quick. Let me remind you, I think both of you have done it, but just in case you haven't, come on. The midterm must be taken by Sunday, March the 12th at 11:30. Quiz 7, which is over normality, is due by Wednesday, March the 15th. And you can begin working on mini project 3, which covers normality, and it's due Sunday, March the 19th. Any questions before we go, ladies?
No, ma'am. Thank you very much.
You're very welcome. Have a good evening.
Okay, no, I don't have any questions.
Okay. Thank you, Deidre. You have a good evening.
All right, you too. Bye.
Bye-bye.